2 when we're done. We're going to solve each one of these equations. We might skip around, but I think we still are going to do most of these. So we're going to start with number 1. Hopefully number 1 is one that you're like, I think I could handle that question. Tell me, and don't get ahead of me, because I might be working things a little bit differently than you would, and I want you to see the other way. I'm not saying you have to change anything. I just want to show you some other things as well as we go through this. So somebody tell me what they would do first in this equation. What would you do first? Distribute the 6. Do y'all all agree that that's legal? 100% legal, and also 100% nothing wrong with that. Okay? It might be safer than what I'm about to show you, but I'm going to show you anyway, because if the numbers get bigger or weirder, maybe that's not something we want to do. Okay? Again, not wrong. That's probably what I would do too, honestly. And, you know, depending on what level I was teaching, that's how I would teach it. But here's one thing we can do. Because there is one term here and one term here, and this 6 is being multiplied, I can divide by 6 right now. I can divide both sides by 6. These 6's cancel out. That leaves me with n plus 5 equals what? 18 divided by 6. 3, negative 3. Good. And then, I mean, the numbers wouldn't have been that terrible had I not divided, but makes them even nicer. Now, what do I do with that 5? Subtract it. And negative 3 minus 5 is negative 8. And that's our answer. Okay? Again, you would get the exact same answer if you distribute, but sometimes we can't do that and we do it at the wrong times. So that's another reason why I want to say that, because if you are of the camp of that's kind of what I would have done, sometimes we do it and it's not legal. So let's look. We're going to jump to number 3. We're going to come back to number 2 because I know you don't like fractions. But let's look at number 3. On number 3, can I start by dividing both sides by 2? No. Why not? This guy right here. Okay? Because I have more than one term though. So because of him, because if I was going to do that, what I would actually do is literally divide every single thing by 2. Not only that, but let's say that negative 5 or that minus 5 wasn't even there. I still don't think I'd want to divide by 2 because 29 is an odd number and then I'd get a fraction, right? So in that case, maybe I would distribute just so I could avoid that. So if we want to do that, we're going to have to add that 5 over there first. So I'm going to leave this as 2 times 2 minus 7y equals, all right, so now I got a negative 29 plus 5. So I'm adding 5 over here. What's that going to give me? Negative 24. Everybody with me so far? And again, I can totally distribute. Absolutely nothing wrong with that. But if you're somebody that you know how to distribute, you draw the little arrows and you still mess it up all the time and you don't know why, maybe you don't want to do it that way. I mean, you know, you got to know yourself. But let's go ahead and we're going to divide both sides by 2. So on the left, I'm going to let these cancel out. I'm left with 2 minus 7y equals what? Negative 12. Okay? And I'm a very transparent person, very open and honest with you. When I first worked this question, and I didn't actually write divide by 2, for some reason, well, I multiplied by 2. So I got a negative 48. I finished the question, and I was like, this answer is weirder than I would expect. So I checked the answer key, and I was like, how the heck did they get that? Then I'm looking at their work, and I'm like, where did they get 12? I'm like, oh, because they did it right. So, you know, your brain, showing work does something for you too, because you see multiply by 2, and I think in my brain I was just like, oh, multiply by 2. So be careful with that stuff. Now here is something that I want to caution you about on something like this, because I think, you know, depending on who really taught you and how you were taught, I was taught by very old school teachers because I'm very old, and in the end your variable had to be on the left. You know, our variables don't always have to be on the left. But also, I would take now, and I don't know if it's because it's the way I was taught, but take my variable. I like for my variable to be positive, but if I want to move that over there or move this over here, here's what you don't want to do, because here's where the majority of you start to make up math. Under no circumstances am I going to move the 12 right now, either way, no matter what I'm doing, because what happens is if you move something, like if I'm going to add this to both sides, here's what a lot of people do. So here, you don't have to write this down, but here's what I see. 2 minus 7y, because I've been doing this forever, like I said, minus 12. So like, okay, I'm going to add 12 to both sides. And they might even write that plus 12, plus 12. That's great. So then we get 14 minus 7y. And then because this zeroes out, that disappears. And then they're like, okay, well now I have to divide. So I guess I'm going to divide both sides by 7. Or they make that, like, then you start making up math. Okay? So don't do that. I mean, you can do an equals 0, but for some reason, that like when things are 0, you think it's not supposed to be there. So be careful. What we can do though, even to leave things negative, I would just go ahead and move the 2, right? So we're going to subtract 2 from both sides. Negative 7y equals what? Negative 12 minus 2 is negative 14. Then I divide both sides by 7 and y equals 2. Now, you can decide what works for you, okay? Because different things work for different people. And if you're like, I really think I might not, up here divide at the right time or whatever, go ahead and distribute. Nothing wrong with that at all. There's going to be other times where you absolutely have to, and you're not going to have that choice. Okay? Any questions at this point? I'm not blowing anybody's minds right now, am I? I mean, hopefully this is, even if it's not super easy, you're like, I can solve equations. I've been doing this. I might need some practice, but it shouldn't seem brand new. All right, so let's look at number 2. So on number 2, before I worry about that 3 that's out there, I know you already don't like this question because you have that negative 4 down there. But does that really make it that bad? No. What's the opposite of division? Multiplication. We're dividing by negative 4, so what should we do? Multiply. Yeah, multiply both sides by negative 4. And when you do that over here, these cancel out. So you're left with 3 times 5 minus 3x equals, now before I worry about what 4 times 15 is, I have a negative times a negative. What does that become? Positive. All right. And when you multiply by 4, you can just double it and double it again. What's 2 times 15? 30. And 2 times 30 is 60. Plus, if you're thinking in terms of 15s, think in terms of time. 4 15-minute intervals is an hour. If you're thinking in terms of 25s, think in terms of money, something like that. But either way, I'm going to get a positive 60. Now, you tell me, do you want to distribute that 3 or do we want to divide it? Divide? Okay, so we're going to divide both sides by 3. And again, it's okay either way as long as you're not making up math. I'm left with 5 minus 3x equals what? 20. All right, then you go ahead and finish that. That's a 2-step equation that hopefully we can finish up just fine. Now, for the sake of space, I guess, so I don't have to write small and you can read it, I don't always show, like I didn't show that I'm subtracting 5 from both sides. I didn't show that I'm dividing both sides by negative 3. Whether or not you do is up to you, but not just because you want to be lazy and leave steps out. If you start leaving steps out and you start making mistakes, then you need to put those steps back in, okay? There's no reward for skipping steps. There's nothing about that. So don't worry about that. Are we good on x equals negative 5? All right. Now, many people think that number 4 is like the thing that nightmares are made of. Yes. All right, so we got a couple of options here. And I kind of went back and forth on like, how do I want to go about this with y'all, because there are different ways to approach this. I could start by multiplying both sides by 16. Raise your hand high and proud if you know without thinking too hard what 16 times 16 is. That's what I thought. So that's probably not a great idea, right? Not that big of a deal. You could go off to the side and figure it out. But this is also a good time to talk about some fraction stuff. So we're going to distribute that on this one. And I'm going to show you what that's going to look like. We're not going to actually do, well, technically we're doing math, but we're not doing any computations. We're just going to write it out. So I'm going to leave on the left-hand side negative 16. That's equal to, okay, then I'm going to distribute, right? So I have negative 15 over 16 times 4 over 5 times q. Right? And then I distribute again. So I'm going to put a plus there, and then negative 15 over 16 times 32 over 3. So hopefully you know that when you multiply two fractions, it's fairly simple. You just multiply straight across. However, if that's the only way you know how to do it, these numbers become extra big and extra yucky. Would you agree with that? So we have to understand another fraction rule that I think students sometimes get mixed up with cross multiplying, because there's different words to say it, and I guess some teachers might even say cross canceling. I don't know what words you use when you teach this stuff, but if I'm going to cross multiply, I'm doing it over equal signs because it's a proportion, right? If I'm going to multiply, and I'm just going to show you what's happening over there with that first one. If I have negative 15, and you don't necessarily have to write this down unless you think you need to. If I'm going to multiply those together like this, and because what I just said, we're just literally multiplying straight across, right? So that's really now just one big fraction with those two things multiplied. Would you agree with that? If I have 2x over x times y, yeah, that's good enough. Then these are being multiplied like these are, then can't I cancel those out and end up with 2 over y? So here's where cross canceling comes in with fractions. Like 15 over 16 and 4/5, I can't reduce either one of those, right? They're reduced all the way. But, and maybe it would help you to actually make it one fraction like that. I think maybe that kind of helps you think about it. Now I can kind of reduce some things. If I just had 4 over 16, could I reduce that fraction? 4 goes into 4 once and goes into 16 4 times, right? And if I had 15 over 5, what does that reduce to? 3 and 1. So this would be 3, and this would be 1. You see how to reduce it like that? Before multiplying. I mean, you can reduce it after you multiply, but those numbers are going to be big, and you're not going to know off the top of your head what to reduce it with. All right, so then here we're going to do the same kind of thing. Well, I have 15 and 3, so that's going to be 5 and 1, right? 32 and 16. 16 goes into 16 once, goes into 32 how many times? 2. Okay? So now my blue numbers look way better than my orange numbers. Would you agree with that? Okay. Now, you also this becomes way more difficult if you're not actually writing things out and keeping things consistent. You just have stuff all over the place that makes it harder. It has nothing to do with good or bad handwriting. It just has to do with, are you actually writing it out? So I've got this negative 16 now, equals. Now this is a negative. I don't want to forget my negative because that could get me in trouble too. In the numerator, I multiply straight across. 3 times 1 is 3. 4 times 1 is 4. And I have this cube. Then this is negative, so that plus I'm going to change to minus. And 5 times 2 is 10. 1 times 1 is 1. So now I just have 10 right here. Do you see how it looks super crazy ugly, but it's really not that bad? You have to, first of all, not freak out and let your brain shut down because you have fractions. And then don't make up math. Okay, we good? Now we still have a fraction. But hopefully you're not as freaked out as you were the first time up there. We have a few options on what to do with this as well. One is to go ahead and move the 10 and then deal with it. But I think for some people, the sooner you get rid of the fraction, the better, because then you can breathe a little bit better. So you can do here, and really in any case where I don't have the parentheses, or I could have basically done it in the first step, but here, I'd like to get rid of that 3/4, right? So just like on the other one where we were going to multiply both sides or whatever, as long as I multiply the entire thing by 4, that means every single term. Every single term. You can't leave out a term, okay? So every single term by 4, then I'm good. Now, okay, at least I don't have to multiply 16 times 16, but I have to multiply 4 times 16. What's 16 times 2? 32. What's 32 times 2? 64. And I'm not saying that you have to do things in your head. You can go off to the side and do your scratch work or your multiplication. That's fine. I just want to show you how to think about numbers. So when I multiply that by 4, I'm going to get a negative 64 equals, then this becomes a negative what? 3, good, negative 3q minus what? 40. Now we can all breathe a little bit better because we don't have any fractions anymore, right? We have taken care of them. So if you haven't already, well, first of all, do we have any questions? Everybody understand why I did everything I did? Yes, ma'am. Where did I get the 4? Okay, so I wanted to get rid of the denominator, right? Just basically kind of like I did here, right? I wanted to get rid of this denominator, so I multiplied both sides by 4. It wasn't as, I guess, complicated or whatever, because this is just one term and one term. I can still basically do that here, but I have to multiply by every single term, and I chose it because it is the denominator. Does that make sense? And then that clears your fraction. It's called clearing your fraction. Okay, good question. Anything else? All right, so then if you haven't already finished it, I'm going to add 40 to both sides, so I get negative 24 equals negative 3q. So what does q equal? 8. We're going to do some other clearing of fractions to kind of help you understand that as well. What questions do you have? Okay, and this is one reason why I think I kind of want to do every single one of these, even though it seems monotonous, because something a little bit different kind of happens in all of them. All right. Number 5. Does number 5 seem super hard? Do number 5 on your own. I think you can do it, and then I'll do it up here and talk you through it. Watching the video, I have to turn the fan on. It might sound like I'm in a wind tunnel, but now once you actually solve for A, then you might be thinking, oh crap, now what do I do? It's okay, at least get there. Now, in a function like this, or an equation like this, did any of you move the 6a and the 7 at the same time in the same step? Okay, because you can, you don't have to. And again, I'm not telling you to skip steps because that you have to decide what steps you need to do or whatever. But if it's not all crazy like some of the rest of these, I can see I want to add 6a to both sides, so that'll give me 16a. And then I want to add 7 to both sides, so that's equal to 28. And I'm there. Okay? Or you can do that in 2 steps, whatever works for you. So then I'm going to divide both sides. Does 16 go into 28 evenly? No. Okay. So A equals 28 over 16. Now, this would most likely be a non-calculator type of situation. And we do not want a decimal. And I know you might think you like decimals better than fractions, but I'm telling you, you don't. The way I would handle this myself, and I'm pretty sure it's what's even on my key over there, there's different ways to do it. What you are taught at some point is to look for the biggest number that divides into both. Well, sometimes that takes forever, right? So you don't need to do that. These are both even numbers, so what are they both divisible by? 2. Okay, so I'm going to divide them both by 2, and I'm going to get 14 over 8. And then I'm going to go, all right, can I divide that again? Yes. And then this is going to give me 7 over 4. I get to a number like that where I'm like, okay, I know I can't reduce that anymore. So you don't have to get fancy and weird and difficult with your fractions. Take a few steps to simplify it. I think that's the best way to do it anyway. And like I said, when I worked it out, that's exactly what I did over here. Okay. Everybody okay with that? So then we just get A equals 7/4. We are not changing a fraction to a decimal. That is it. We're good? All right. So let's look at number 6. We have fractions, okay? I want to get rid of those, but I have a couple things to decide. Do I want to do the fraction first? Am I going to want to distribute that negative 1/3, whatever? So when I look at this first, well, since this is 9, if I distributed the negative 1/3 to the 9, that actually works out pretty well, right? But then to the 2, that would give me 2/3. If this number was divisible by 3, maybe I would go ahead and do that, and that would kind of take care of one fraction. But since it doesn't, I'm not going to do that. let's look at this as we are going to clear our fractions. And before we distribute, it can be before or after, but I'm going to do it before so we make sure we understand also what you do and don't multiply it by. So we chose to multiply by 4 right here because of this denominator. Well, I have these two. Well, apparently I'm using an eraser. I have these two that I need to deal with here. So if I just multiply by 3, is that going to be good enough? No. If I multiply by 6, 6 will take care of this denominator completely, and it'll also take care of this one. I just got to make sure I pay attention to my numerator. Okay? So do you understand how we're deciding on 6? All good with that? So I'm going to multiply the whole thing by 6. Every single term. So let's talk about the terms. I have this is one term here, this is one term here, this is all one term here. So I'm multiplying the 6 times the negative 1/3. I am not multiplying 6 by 2 and 9. You with me? You don't multiply by everything you see because all that's being multiplied together anyway. So 6 times 5/6. All right, so what's that going to become? 5. So that's going to give me 5W plus. All right, 6 times 21. Again, you can go off to the side and do it, but you can separate it like this too. I think 6 times 20 is pretty easy. What's 6 times 20? 120. And what's 6 times 1? 6. 6. Okay, here's what I'm saying out loud. So we have this 21. I'm splitting it up into 20 and 1, right? So 6 times 20 is 120. 6 times 1 is 6. And then when you add them together, you get 126. Which is basically what you're doing when you multiply off on the side, but you can kind of, again, it's not all about doing it in your head, but it is sometimes about just simplifying what you're thinking. So this is plus 126. Now, 6 times a negative 1/3, I know is going to be negative. We're going to be very careful with our negatives. So 6 times 1/3 would be 6 over 3, which is what? 2. Okay, 2. And then I get 2W minus 9. Any questions about why I did or didn't do anything in those steps? Don't be afraid to ask a question. All right. Now, could I divide everything by a negative 2 right now to get rid of this? Yes. And that would take care of this. This is even. That's fine. But then this would give me 5/2, and then I'm right back with a fraction. So I'm thinking I don't want to do it that way, right? Instead, I want to distribute. And these decisions, as you're working through things, they don't take that long. They take another second or two to just think about what you have and what you want to do. So we're going to distribute this. So go ahead and rewrite that and distribute that. So we get 5W plus 126 equals negative 4W. What's going to come after that? Plus 18. Now here, you can decide what you want to move first. Again, you can move the constants first or the variables first. I always move the variables first. Again, I don't know why. It might have been the way it was forced down my throat, but it really doesn't matter. But if I'm going to move the variables first, would you rather move the 5 or the 4W? The 4W? I mean, that's what I would do, but could I move the 5 instead? Absolutely. Just be careful with your signs. So I'm going to add 4W to both sides, and I'm going to get 9W plus 126 equals 18. Okay. Now I'm going to subtract 126 from both sides. You don't have to tell me what the number is, but tell me something about the number. It's going to be what? Negative. Okay, so I'm going to do negative. Then really, aren't I just doing 126 minus 18? Okay. So it's really just going to be 100 and something, and then 26 minus 18 is going to be 8, right? So I get negative 108. Then I divide both sides by 9, and if you know your multiplication facts to 9, then you do know what W is. But if not, we can do it a step at a time. Again, we'll get negative 108 over 9. Well, is 108 divisible by 9? Remember how to find that out? I add 1 and 8, I get 9. It is. 9 goes into 10 once, so W equals negative. 9 goes into 10 once with 1 left over, and then negative 12. Because 9 times 12 is 108. Something that's important to know. Or however you divide and figure it out. Again, I am not going to make you change anything you are doing unless you're doing it wrong. Just trying to show you in case you're not sure, you're still shaky on things, you might choose to do things a little bit differently. Okay, we okay with that? What questions you got? Okay. So let me ask you a question before we do number 7. If I have 2x plus 3 divided by 2, can I cancel those 2's out? No, because of this addition, right? If I have 2x plus 6 over 2, could I reduce that? The answer is yes. Technically, what you would do, so I can't reduce that at all. What you would do here is you would factor that out, and then you get this 2, and then you cancel that out like that, okay? But another way to look at it is just like anything else we did, as long as you multiply both of them by 2, or I'm sorry, divide both of them by 2, then you're okay, right? So if you look at number 7, probably the safest thing for everybody to do is distribute. But if I did divide both sides by -5, I could, as long as I divide both of those, just like when we multiplied every single thing, that would be okay and that would be legal. All right, now, what do you want to do? Do you want to distribute or do you want to divide? Divide? Okay. If you're not going to speak up and participate, then we're just going to do what somebody says. So I'm going to divide, and I want to divide by a -5. So I'm going to divide everything by a -5. Okay? These cancel out. Actually, what I need to do, let me do it this way. The safer thing to do here is to do it like this. -5, -5, -5. I think that's safer. Right? We want to be safe so we don't make up math. We cancel that out. I get 8p plus 6 equals, what would the first thing be? -1, then what? Plus p. Very good. But that only works if you do every single term. Okay? We're good? All right, so go ahead and finish this one up. I'm going to assume we don't need. Now, are you going to solve an easy equation sometime and maybe make a mistake? Yes. Am I going to? Yes. So making a mistake is one thing. Not having a clue what you're doing is something completely different. So if as I'm going through this, you're like, oh, she's assuming I know all this, I kind of need to know. You don't have to shout it out but I kind of need to know if I need to dial it back a little bit for some people, and we can do that separately. But all right, so let's look at 8. Any questions on 7? We're all good on that? Okay. So one thing we've been doing is dividing by whatever number is out here. Well, 16 is divisible by 8. Can I just cancel this 8 out and divide the 16 by 8 and move on? No, because there are 3 terms here. And since there's nothing out there, that would just put it over 8, and then I'm making my life more difficult, right? So in this case, we want to distribute. But here is probably the number 1 most made mistake in, I don't know, equation history. And it doesn't matter how strong of a student you are or whatever. I mean, it happens all the time. Not only do I have to distribute this 8, you have to distribute the negative. And the signs on things, that's what can get you in hot water faster than anything else. So this actually gives me 16 minus 7m minus 3 equals 8 minus 8m. Those signs, distributing those signs, whether there's a number there or not, and especially if there's not a number there, that's when it really goes down the tubes. All right, now, here's what I see every now and then. Not so much, but because some students like to move the constants first. they'll be at this step, and then they'll add 3 to both sides. Then they'll subtract 16 to both sides. Not wrong, but in my opinion, you're making your life harder, right? So make sure you're combining your terms. You get 13 minus 7m equals 8 minus 8m. And let's move the m's first. You want to move the 7 or the 8? 7? Okay, so we're going to add 7m to both sides, so we get 13 equals 8. And then if I add 7m to this right here, what do I have? Negative m. Okay, good. Then we subtract 8 from both sides, and what's 13 minus 8? 5. And so 5 equals negative m. Don't drop off that negative. So then what is m equal? Negative 5. And I'm writing it like this because the m was on the right the whole time, totally legal. But I'm also going to tell you, and I don't even realize I'm doing it most of the time, I'm going to put the m on the left, again, because I was kind of trained in the days where it has to be on the left or it's illegal, which is totally not true. I don't know why they made us do that. But out of habit, I'm not even paying attention when I do it. It doesn't matter which way it is there. Everybody okay with that? So let me just show you something. If you are somebody that messes up their signs a lot, because you kind of know where your faults are, I think. You got to be honest with yourself. Had I moved the 8, then I would have had a positive m, and I wouldn't have had to worry about this. It doesn't matter how you do it. You get the same answer either way, but you kind of have to know yourself, and maybe I should do it the other way. It's totally fine. Okay? We good? All right, y'all are doing a great job. I know this is not the most exciting thing you've ever done. We're just problems. I think we'll get to... Yeah, let's at least need to get through here, I think, today. All right, so let's look at 10. I'm sorry, 9. Duh. Let's look at 9. We got a whole lot going on in that numerator. Now you have a couple of options. You can deal with the numerator a little bit first and then worry about the fraction. However, I don't think that's the best way to do it because some of you won't rewrite the whole fraction. I think in this case, the best thing to do is deal with the fraction first, okay? So in order to do that, we'd multiply both sides by what? 2. Okay, so I multiply both sides by 2. Since there are there's more than one term over here, I have to put that in parentheses. Okay, so we're going to write this out. These cancel out. I'm left with 10x plus 17 minus x minus 9 equals 2 times 3x plus 1. Now, could I have distributed as I rewrote it? Absolutely. Could I have distributed the negative as I rewrote the numerator? Absolutely. I just don't want to lose anybody, so I'm not skipping many steps right now. Everybody with me here? Okay, so now I'm going to clean up both sides. I'm just going to rewrite the 10x plus 17. Then I'm going to distribute this negative x plus 9 equals 6x plus 2. Okay. And even if you're writing more steps than you'd like, skipping steps is not always the way to go. Maybe, but whatever. Okay? Everybody with me here? All right, then you finish this one up. Any questions at all? All right. So let's look at 10. I got that 9/8. Well, I got a lot of fractions there. And I might have to take care of fractions more than once. But I think let's go ahead and take care of that 9/8 first. Okay? If I want to take care of that 9/8 first, what would I multiply both sides by? 8. Okay, good. Move the side 8. So because of this, I'm going to multiply both sides by 8. And there's just one big term on both sides. So these 8's cancel out. That leaves me with 9 times 4 minus 1/2a equals, and I got to do 8 times 3. What's 8 times 3? 24. And that's going to be 1/4 A plus 5 halves. Everybody with me so far? So now, before I worry about the fractions on the inside, because I would probably be making up math if I tried to do something right now, I'm going to go ahead and distribute. So I'm going to get 9 times 4 is 36, minus 9 times 1/2 is 9 halves, equals, now what's 24 divided by 4? 6, so this is 6A. And then, if you look at this is really 24 divided by 2 times 5, right? What's 24 divided by 2? 12. And 12 times 5 is 60. Good. Now, I'd like to get rid of the 9 halves issue there. So what would I multiply both sides by? 2. And remember, it's every single term. I cannot stress that enough. Don't leave anything out. 2 times 36 is what? 72. Then that would be minus what? 9A equals what? 12A plus 120. Every single term. Everybody with me? Okay. You want to move the 9 or the 12? Like the number is going to be the same on either side. It's just the sign that would change. So I think I want to move the 9. So we'll have the 72 equals, what's 9 plus 12? 21. Wait. Oh, think in terms of money. You got 12 bucks. I give you another 9 bucks. What do you have? Right? You got 21. So 21A plus 120. Then what am I going to do? Okay, subtract 120. So, should have been writing a little bit smaller here. That's 120 minus 72. 48. So I get 48, negative 48, right? Equals 21A. So now I'm going to have that negative 48 over 21. All right, so then instead of guessing and checking through 1,000 numbers, the only factors of 21 are 3 and 7, right? 48 is not divisible by 7, but it is divisible by 3. What do you get? It's 16. Everybody okay with that? All right. Any questions? Okay. So special cases. We can get through those before the bell rings, and I want to get through these, that way I can give you your assignment and tell you what to do and what not to do. Go ahead and work out 11. Get as far as you can on 11, because I think you can at this point. And if you can't, if you have questions, let me know. Okay, so when you get here, 2 different things could happen because depending on whether or not you move the number first or you move the variable first or whatever. But if I'm going to here subtract 3c from both sides, those cancel, or those zero out, I get 1 equals 5. Is that a true statement? No. And so what does that mean your answer is? Anybody remember? No solution. solution. If it's a false statement, it is no solution. So you might have gotten like 0 equals 4 if you had moved the other, you know. Either way, it won't be a true statement. Okay? We good on that? So let's do this one. We'll go ahead and do this one together. So we get 40 minus 8x equals, and I'm going to distribute and get negative 8x plus 40. Right? So again, you could move the number or the variable. Either way, the same type of thing is going to happen. I would add 8x to both sides. These 0 out, these 0 out. We get 40 equals 40. Is that a true statement? Yes. So then what do you think the solution is? All real numbers. Good. You get a true statement, it's all real numbers. You get a false statement, it is no solution. Okay? Now, we still have a lot to go through, and we have like a whole thing of these word problems. So I'm going to give you this. I would say just the front. Do the front because I want to talk about the proportion stuff. And then do the front. Don't worry about the back just yet. Okay. And hopefully this will be fairly simple for you. Of course, we all make careless, weird mistakes because we're human, but then you can go ahead and you can put that on page, I think it was 23. Get your phones. Don't forget your phones. I know that was a long day of working lots of equations. Good job.